All right, we're starting our unit on exponential function, and today we're going to focus specifically on exponential growth. So things will be increasing exponentially today. All right, so write this equation down. Here is the general form for exponential functions. Y equals A times B to the power of X. So where A and B would be numbers. So you don't have to write this down, but just so you can kind of see, maybe it's 2 times 3 to the power of X. Or Y equals 1/2 times 4 to the power of X. So the thing they have in common is that the variable is the exponent, and then here we have numbers. All right, so now we're going to talk about details about what the A represents and what the B represents. We are talking about growth. So we're going to show what that means for these numbers, and then in a later video we'll talk about how the exponential function can also decrease. All right, so for starters, my A value cannot be 0. And then the B value, for us to have something growing, the B value has to be greater than 1. So it's not just positive numbers, it's greater than 1. So an example could be Y equals 2, and then the B value for it to be growth has to be greater than 1, so it could be 3 to the power of X. And we're going to see what happens with these numbers, where they show up on tables, on graphs, and in story problems. But just to kind of give you a heads up, the A value, so the number 2 here, A, on a graph, that's your y-intercept. And then A is also, in a story problem, it's like our starting amount. And then going in relation, so with that y-intercept, it would be when X is 0. And now looking at B, that is what determines increasing or decreasing our growth. So for this case, our B is going to be our growth rate, growth factor. All right, so now we're going to look at how all of this applies into a table of values. All right, for starters, you could maybe pause the video quick and copy this table down in your notes. All right, so we're going to look at the pattern that we have. And we're going to first just start by continuing the pattern. Being able to recognize a pattern and continue a pattern is important. So the X values, that's pretty easy. 0, 1, 2, 3. Let's continue that pattern. 4 and 5. All right, so what is happening with the Y values? Let's see, from 8 to 16, we're multiplying by 2. 16 to 32, multiplying by 2, multiplying by 2. So exponential function is when we are multiplying or dividing by a factor. So we're not adding or subtracting. So let's continue that. 64 times 2 is 128. All right, 128 times 2 is 256. So now, can we write an equation for the table of values, taking what we learned before? All right, so A, if you remember, that is the y-intercept, the starting amount. It's the number that shows up when X is 0. So A is when X is 0. So look at your table. Boom. Because X is 0, that means A is 8. And then the B, remember, that's the growth rate. How are things growing? Times 2, times 2, times 2. So that means that B is 2. So we're going to write out our formula or our equation. y equals a is 8 times b is 2 to the power of x. And we can also do a quick check. Let's just see what happens when we plug in 4. Let's see, y equals 8 times 2 to the power of 4. Y equals 8 times 2 to the power of 4 is 16, and 8 times 16 is 128, so it checks. All right, so now we're going to look at a graph. So we are going to graph the function y equals 1/2 times 4 to the power of x. All right, so we're going to do this by just making an xy table. We're going to pick values for x, plug them in, and evaluate them. So I always suggest with exponential function, get some negative, always use 0, get some positive. So I'm just going to do -1, 0, 1, and 2. And now we just plug them in. So 1/2 times 4 to the power of -1. Well, let's see, that would be 1/2 times 1/4, because a negative exponent means fraction, and so this is 1/8. So I'm going to plot the point, -1, 1/8. So -1, and I'm going to go up a tiny bit. Okay, so now plug in 0. So 1/2 times 4 to the power of 0. 4 to the power of 0 is 1, and 1/2 times 1 is 1/2. So I'll plot the point 0, 1/2. So 0, I'm going to go up halfway. All right, let's see what happens when I plug in 1. 1/2 times 4 to the power of 1. So that's just 1/2 times 4, which is 2. So I'm plotting the point 1, 2. 1, 2. Last one, 1/2 times 4 squared. So that's 1/2 times 16, which is 8. So 2, 8. Over 2, up 8. So if you remember, we talked about in class how I can cut numbers in half forever and ever and ever, and they will keep getting smaller and smaller and smaller, and they will never touch 0 and never go below 0. But this way, they're increasing very quickly. So this line right here, it's getting close to the x-axis, and even though on here it's touching, but technically it will never touch that x-axis, and it will never go below the x-axis. So whenever we have that, a line getting close to something infinitely, but it never crosses, there's a name for it. It's called an asymptote. It's kind of a silly name, but you're going to hear it a lot in this unit. All right, so now let's talk about domain and range. Domain, so those are my x values. Notice how it's going left forever, and it will go right forever. So domain, all real numbers. Range, it's going to go up forever, but it's never going below 0. It will also never touch 0, so its y is greater than 0. All right, now we're going to apply a story problem to the exponential function. Into this equation, y equals a times b to the power of x, we have to figure out what is a and what is b. So a population of 100 insects, that is my starting amount. So if it's my starting amount, there's my a. This population triples. Okay, well, triples, boom, right there, that's my growth rate. That means that's my b. And what does triples mean? It means that it's being multiplied by 3. So this population is going to triple in size every month. And then how many insects would there be after 6 months? Well, first, I'm just going to write my equation. Y equals 100 times 3 to the power of x. So x is going to be how many times the tripling occurs. All right, so if it triples every month, and then in 6 months, that means x is 6. So y equals 100 times 3 to the power of 6. Order of operations, do your exponent first. 3 to the power of 6 is 729. And we have to multiply that by 100, which equals 72,900. So if it has this growth rate, 100 insects will turn into over 72,000 in only 6 months. All right, last question. This involves a percentage. So just a heads up, there's going to be a little trick to this one. So a tax revenue that a small city receives is increasing by 3.5% per year. So there's your growth rate. This is going to be B. In 2015, the city received 250,000. So this is like the starting amount if we were starting from this year. So there's my A. In tax revenue, determine the tax revenue in each of the following years. So 220, how many years have passed? 5 years from 2015. And then 2030, 15 years have passed. All right, but let's think about this first. So I have y equals 250,000, and then I've got my b to the power of x. So it's 3.5%. Well, first, how do we write a percentage as an equivalent decimal? We move the decimal to the left twice, add a 0, so it's 0.035. But we're dealing with an increase. We're dealing with something that's growing. And what I said at the beginning was that a growth factor means the b value has to be greater than 1. So what you do when you have percentages, you always do 1 plus the percentage, 0.035. All right, so for this one to evaluate 2020, it would be y equals 250,000 times, that is, oops, I didn't mean to erase that, 1.035 to the power of 5. And then for the other one, y equals 250,000 times 1.035 to the power of 15. Pause the video, get a calculator out, see if you can evaluate that correctly. All right, check your answers. In 5 years, it will increase from 250,000 to 296,921 and 58 cents. And then in 15 years, it goes all the way up to 352,649 and 69 cents. So there is your introduction to the exponential function, specifically exponential growth.